Hello, and welcome to the third video in our series on probability for grade 12 essential math. Today we're going to take a look at expected value. Expected value is a way to use probability calculations to predict whether you should play a game or whether you should, for example, for business, do advertising, or for insurance. This formula that we're using today is the formula that is used to calculate your home insurance or to calculate your vehicle insurance. But the company that calculates your insurance will take into account more factors, but it all boils down to this basic formula. So let's take a look at this formula. Expected value, here's our formula. You take your probability of winnings times the amount that you can win, subtract the cost, or how much it costs to play. I'm talking about this in terms of a game, but the general idea here is this is your average gain or your average winnings. When you're looking at this, this could be how much you make, how much revenue you make for a business. Here is how much you lose, or this is how much expenses you have as a business. Now, in terms of insurance, this could be, for example, when MPI looks at this, they say, hey, how much does it cost to pay out? How likely are you to get in an accident? Times how much does it cost to pay out to fix your car or replace it? And then this here is your premium, your insurance premium. For MPI to make money, they use this formula because it's an expected value calculation. Same thing for life insurance, same thing for many different things. We're going to look at this in terms of some simple dice games and card games because that's a little bit easier to calculate, but the principle is exactly the same. So here we go. Here's our first example. Let's say that you're wanting to play a card game. The card game goes like this. You're given a deck of cards. You have to draw one card from it. If you draw an ace from a deck, you win $20. It costs $2 in order to play. Now, the question is, should you play this game? Well, when we ask this question, should you play this game, in this unit, we're talking about based on the expected value. We're not talking about, is this game fun or not? We're talking about, is this game financially profitable for you? So here we go. In order to do this, I need my formula. So my expected value is my probability of winning times the amount that I can win, and I'm going to subtract the cost. Nice and easy. The probability of winning, in this case, in a deck of cards, there are 4 cards, 4 aces, and there are 52 cards in a standard deck of cards. Now, I take that times the amount that I can win is $20. And the cost of this game is $2. So my expected value is 4 over 52 times 20 minus 2. Now, to work this out, what I'm going to do is I'm going to look at this and make sure that you're doing this correctly using your BEDMAS. So I take 4 over 52 times 20, and this works out to my expected value is negative $0.46 in this case. Now, the important thing with this is this sign out here. That is the important part. The reason for that is this means on average, we are going to lose money when we play this game. Every time I play this game, I'm expecting to lose 46 cents, which might not sound like a lot, and it doesn't mean that every time you play, you're going to lose 46 cents, because you can't. You're either going to lose $2 because you didn't win anything, or you're going to gain $20 or make $18 because you spent $2. But on average, if I play a lot of times, I'm going to lose money. In this case, the negative is the important thing. I'm saying this is my average loss, so no, the expected value is negative. Based on this, I should not play the game. So you should not play. Now, please notice when you're answering a question like this, you need to refer to the expected value being negative. That's important. This means you're going to lose money. You need to refer to that in somehow when you're answering a question like this. So let's take a look at another example. Now, we can look at examples based on advertising. For example, when you're sending out advertisements, you're effectively gambling that someone is going to respond to that and buy your product. Or you could talk about, as I said, insurance. What's the chance of, for life insurance, what's the chance of you dying? Well, that might be based on many different things, such as your age, such as your gender, such as your whether you smoke or not. So many different things like that will affect your probability of dying for life insurance. So they're going to need to tinker with that in order to make your insurance premium profitable for them. For advertisement, same thing. You need to say, well, if I'm not going to expect to get enough money back from this, it's not worth doing the advertisement. Or, again, based on the advertisement, you might say, no, this is worth it because I'm expecting to sell a lot based on this advertisement. So let's take a look at another example here. This one is a little bit more complicated. So here we have a dice game. And we're doing a dice game here because this is a little bit simpler and a little bit easier to look at. So let's say you're playing a dice game where if you roll a 6, you win $3. If you roll a 4 or 5, you win $2. If you roll a 1 to 3, you lose. And it only costs you $1 to play. Should be pretty straightforward. Now, if I look at my formula here, I have the probability of winning times the amount that I can win. You may notice that I actually have two different options here. Both this one and this one, I win something. This third one, I do not win. So what I can do is I can say this chunk here, I can repeat that for each time that I do this. I can say, well, probability of winning based on this, or rolling a 6, probability of winning based on rolling a 4 or 5. And I can use those and add them together to get my average gain here, my average winnings. If I look at this, if I'm rolling a 6, my probability of winning is 1/6. If I'm rolling a 4 or 5, my probability of winning is 2/6. Great. This one here, I'm not gaining anything, so I can actually ignore it. Now I can treat this similarly to a weighted mean question. I have this in sort of a little table here, so I can actually use this to calculate or to help me calculate this. This is my probability of winning. This is my winnings. And what I can do is I can start by multiplying these together. So 1/6 times 3 just works out to 0.5. 2/6 times 2 works out to 0.66667. I'm writing more decimal places here because I don't want to round too early. I can now add these together. I'm going to add those together, and that works out to 1.16667. 1.16667. There we go. So this here is my average winnings. And I can use that in my formula now. So I can go 1.16667 minus my cost. My cost is only $1. And that works out to $0.17, rounding it off only at the end here. Now, you may notice this is positive. That's good. So this being positive is the important part here. I put a little exclamation point there. That's important because this means that you're expecting to gain 17 cents every time you play this game. That might not sound like a lot, but we're not worried about how much this is. We're just saying it's positive. 17 cents every time I play this game? Well, I can play this game quickly. Oh, look, I won $2. Oh, look, I won $2. Oh, look, I won $3. Oh, I didn't win anything. Oh, I didn't win anything. And I can play this really quickly. So the actual amount here doesn't matter. What matters is the fact that it's positive. So this being positive means, yes, I should play this because I'm going to gain money. This has been our video on expected value. I hope that this has helped, and I hope that you have a great day.